All right, so we're going to be looking at how to solve equations that contain radicals. Okay, solving equations with radicals. So an example of what an equation that has a radical would be this first example, the square root of 3x is equal to 9. So these are the type of equations that we're going to be looking at in this section. So what must do? Number one, isolate one of the radicals on one side of the equation. This is going to be so key in this section. Isolate means we want the radical by itself on one side. And then it says any equation may have more than one radical. And if we come across an equation that has more than one radical, we will attack that question and show you how to solve that when it has more than one radical. Step 2, raise both sides of the equation to the power. Raise both sides of the equation to the power corresponding to the index of the radical. So if the index is 2, then we have to raise that equation to the power of 2. If the index is 3, we have to raise that equation to negate it will be the power of 3. Step 3, if the equation still contains a radical, repeat steps 1 and 2. We're going to solve the equation and then we're going to check our answers, check your solutions. In this section is going to be so key that we check our solutions because we may have a solution that is extraneous. And extraneous meaning extra, a solution is a solution found when solving an equation that does not satisfy the original equation. So yes, we're going to solve it, come up with an answer, but when we check our solution, it doesn't work out at all. So we would call that solution extraneous. So as we go over these examples, I want you to think about, negation, meaning our opposites. What's the opposite of addition? It would be subtraction. For division, it would be multiplication. So whenever we look at something such as like the square root, the cube root, the fourth root, the fifth root, we can keep going. To negate a radical, you always take or find a number. The number will be the index and you will raise it to that power. So for this example, the square root, the index is 2. What would negate the index of 2? It would be the power of 2, meaning the exponent. The cube root of 3, the index is 3. What negates the cube? The power of 3. And it's going to cancel out. What negates the index of 4? The power of 4. So I want you to understand what's going to take place, because in order for us to solve an equation that contains the radical, we're going to have to use step 2, where we raise both sides of the equation to the power corresponding to the index of the radical. So let's take a look at these examples that I have listed here. We have the square root of 3x is equal to 9, and we want to solve for x. Well, to solve for x, number one, is the square root by itself on one side? Yes, it is. That's what we want. Then what we want to do next is we want to raise both sides of the equation by the power of 2, because we want to get rid of this radical, this square root. So to do so, I said it before, we're going to square both sides. What you do on one side of an equation, you have to do on the other. What's going to take place? That square root and that exponent of 2 on the left hand side will cancel out. Then we have here 3x is equal to 9 squared, which gives us 81. And then we have an equation now that doesn't have a radical, and we can solve. To do so, we're going to divide by 3, and we have x is equal to 27. Solving an equation that contains a radical, it is going to be key that you check your work. We want to know if we take this solution of 27 that we found, go back to the original equation, substitute 27 in for x. We get the square root of 81. And the square root of 81 is 9. If we come up with the statement that is true, and this is true, 9 is equal to 9, then 27 is the solution to this equation. Let's look at the next example. The square root of 2 is equal to -4. How would I negate this square root? By raising both sides of the equation by the power of 2. The square root and the exponent of 2 cancels out. We have 2x is equal to the quantity of -4 squared, that is 16. And now we have an equation that doesn't have a radical. We're going to solve for x by dividing by 2. And we have x is equal to, what would that give us? 8. Now check your work. We're going to go back to the original equation, and we're going to substitute 8 in for x. So we have here the square root of 2 times 8 under the radical sign. Take this, multiply 2 and 8, we have 16. Take the square root of 16, which is 4. So look at this statement that we have when we check our work. Is this a true statement? No, this is not true. So what this is saying, this is where that extraneous solution, the definition for extraneous solution, comes into play. If this doesn't equal to it, when we substitute 8 back into the original equation, we would say that this solution is extraneous. Therefore, this equation does not have a solution, so we would say we can use this symbol for no solution, or we can write the word out that says no solution. Last example on this page here, we have the cube root of 20x is equal to -4. So what would negate a cube, an index of 3? Raising both sides of the equation by the power of 3. So on the left hand side, the cube root of 3 and the exponent of 3 cancels out. We have 20x is equal to the quantity of -4 cubed, which gives us 64. Now, so we have here 20x is equal to 64. We're going to divide by 20. And we have x is equal to 20 cannot divide into 64 evenly. And let's make a correction here. The quantity of -4 cubed is going to be -64. So let me make that negative. Make that correction. What can we divide out of 64 and 20? -64 and 20. We can divide a 4 out. So this is going to reduce to -16 over 5. So let's see if this answer is correct. We don't want it to be, hopefully not extraneous. So here's the original question. The cube root of 20x equals to -4. we're going to plug in negative 16 over 5. Well, 5 can go into 24 times. This is all under the radical sign. 4 times negative 16 would give us negative 64. And the cube root of negative 64 is negative 4. So this is a true statement. Therefore, x equals to negative 16 over 5 is the solution.